to go ahead and look at the example of a hot air balloon as we've looked at in class. So we're going to look at three different types of energies: thermal energy, gravitational potential energy, and kinetic energy of motion. I have these written here, and thermal energy we are representing with a T or a KT, K meaning kinetic. Gravitational potential energy is represented by a G or a PG, the P being potential, or kinetic energy of motion, which we're going to represent with either an M or a KM, since it is a type of kinetic energy. Let's go ahead and draw our ground so that we know where our hot air balloon is lifting up from. So let's go ahead and start out with our hot air balloon on the bottom. And we have our hot air balloon here. And it's going to start with one particular type of energy, thermal energy. I'm going to go with 10 thermal energies. So that's 3, 4, 5, 6, 7, 8, 9, 10. We have 10 thermal energies, of course, coming from the fire, which comes from the fuel. That's another type of energy. But we're just going to work with the thermal energy, starting with that now. Now, of course, the purpose of the thermal energy is to be able to lift the hot air balloon up. So we're going to have the hot air balloon lifted above the ground, and that thermal energy is going to go ahead and turn into something else. It needs to, one, move. We're going to call that M for motion energy. And then we're also going to say, since it's moved up, it also needs some potential energy. So we have G and G. We've got 2 G's and 2 M's. That leaves us over with 6 T's that have not been touched. 1, 2, 3, 4, 5, 6 T's. As time goes on, of course, hopefully not that long a time, our basket gets lifted up. This is the most beautiful drawing of a hot air balloon you've seen. And we've got our, now let's say that our speed is the same, so our M is going to be the same. The G's, we're going to be higher up in the air, so we need more G's. And then we have still some T's left over. So we have 1, 2, 3, 4 T's, 4 G's, and 2 M's. We're going to actually take accounting of that by looking at it as a graph. So if we were to take 1, 2, 3, 4, 5, we're going to have each one of these lines represent 2 energy units. That makes a total of 10. And then we're going to graph the kinetic energy of thermal energy, the kinetic of motion, and the potential of gravitational energy. So we start out with all kinetic energy, 10 units, and we have that here. Then we go to the next stage, and of course some of that kinetic energy of thermal turns into kinetic energy of motion. So we actually end up having 6 thermal energy units. Then we have 2 of our motion energy units, 2. And then for our potential units, we also have 2. Okay? So some of our thermal energy has gone into both motion and gravitational. So our last graph here shows that the thermal energy is further decreasing. Thermal energy, we have 1, 2, 3, 4. So thermal energy is 4 units of it. Then we have our kinetic energy of motion, and we're going to stay with 2 of those units because we're just saying that our balloon is going up at the same speed. And then potential energy, gravitational, is then 4. So we have a total of 4 plus 2 plus 4 is 10. 2 plus 2 plus 6 is 10, and then a total of 10. So that is my version of the energy of a hot air balloon.